Hello, Natalie Terry here from Natematics, here to take you through how to solve a two-step linear equation. However, it's not actually an equation. Show you in a second when you look at it. I've just been sent it by a student, so I'm just going to share my screen. I've actually done this once already and I was just completely reading numbers wrong. I think it's because I had a bit of a tired day yesterday. So here we go. So this is a two-step inequality. Why is it an inequality? Well, there's no equal sign there. It's either greater than or equal to. This is what we call an inequality. So it's greater than, less than, greater than or equal to, or less than or equal to. They are all inequalities. So what have we got? It says solve 8x minus 3 is greater than or equal to 6x plus 4. So before I go on and just show you how to do it, I'll give you some hints. I'm just going to give you a couple of extra bits here. So what is this? Well, it means that we are going to be finding, it always seems to, when I first start this, it always takes a while to wake up. So we've got to find a value of x. Now this x means that it's representing a number. And we know that 8 lots of this number, take away 3, is going to be greater than or equal to this number again, multiplied by 6, added to 4. Now, when we do inequalities, we kind of treat them exactly like we would do an equation. There's only one slight difference, and that's when we divide by negative numbers. But for this one, you haven't got to worry about that. So let me take you through, and the steps, to be fair, are pretty much like solving a two-step linear equation. We're just going to make sure that we have the greater than or equal sign there as we're going through it. So first step is, when you've got two terms either side of an equal sign or an inequality sign where they have x in them, or whatever letter it is that we're looking at, what variable, we need to subtract the smallest x from both sides. So by that I mean the term that has the smallest coefficient of the x. So that means here we've got 8x and we've also got 6x. So which one is the smallest? That's the 6x here. So we're going to subtract that from both sides of the equation, or sorry, inequality. If I say equation, replace it with inequality, okay? So, and why do we do it from both sides? Remember, it's a balancing scale. So we're saying what's on the left is greater than or equal to what's on the right. Now, if we were to subtract something from one side and not the other, it just wouldn't work. So you have to do it to both sides. So we do that, do the maths, and we end up with, so 8x, take away 6x, makes 2x. Don't do anything to the minus 3 because the x is something completely different to the number. And we're left with the plus 4 on the right-hand side. Okay, so next step is move any integers or numbers. I say or numbers because it's not always integers in these equations. However, most of the time they are. So move them so that we end up with the term that's got an x in it on one side and everything else on the other. Okay, I used to make a joke actually that the 2 and whatever's next to the x, so it could be something dividing it actually, they're best friends. They have to stay together right till the end. We take everything else out of the picture first. So they're having a little party on this side, the 2x minus 3. The minus 3's got to go first because the 2 stays right till the end. So how do we remove a minus 3? Well, we think, what maths can we do? So what can we do to a minus 3 to turn it into 0? So to take rid of it from this side and to move it onto that side. Now, when I was in school back in the 80s, we used to just say, okay, we'll take it to the other side and it becomes a plus 3. That's exactly the same. We are still doing that and the maths hasn't changed. But to understand what we're doing, what we say is we actually need to add 3 to both sides because that effectively does the same thing. Because if you add 3 to this side, it becomes 0. Add 3 to this side, it becomes 7. So you're doing exactly the same thing. So whichever way you understand it, stick with it, please. So we now end up with 2x is greater than or equal to 7. So 2 lots of this number that we don't know yet, but we're going to find out, is greater than or equal to 7. So this is kind of like that last stage. So we want to look at we want to get x on its own. So how are we going to get x on its own? Well, at the minute, there's this 2 clinging to it, wants, you know, best friends, wants to stay there till right till the end. But unfortunately, it's going to have to go now. So how do we get rid of that 2? Well, we do the opposite. We do the inverse. So at the minute, the x is being multiplied by that 2. So we apply the inverse, which means we divide both sides by -2. Sorry, not -2, divide both sides by 2. So by doing that, you end up with x on the left-hand side and 3.5 or 3.5 on the right-hand side. Now, I personally prefer to use fractions, so you'd with 3.5. In this case, it doesn't matter so much because 0.5 is exactly the same as a half. It's when people turn a third into 0.3. No, don't do that. Thank you. So there we are. So x, this value of x has got to be greater than or equal to 3.5. So, and sometimes you get questions where it says, what values of x, what could x actually be? Well, it's not telling me that x is an integer. So x can be 3.5, 3.6, 3.7, 1,063.4. As long as it's bigger than or equal to 3.5, then that inequality would work. And sometimes as a bit of a check, pop a number in. So for example, try x equals 4. So 8 times 4 is 32. Take away 3 is, what did I say, 29. So that should be greater than or equal to 6 times 4, which is 24, plus 4, which is 8. So yes, 29 is greater than 28. Therefore, it works. Hope that helps. I'm just going to stop my sharing now and you're back to my full face. So hopefully that helps. As I say, inequalities you treat pretty much the same as an equation when you're trying to solve them. It's only when you have to divide by maybe a negative number that your inequality changes size. But I will share something on that at some point in the future, but just something to be aware of if you're watching this on its own, perhaps as part of a subscription. So take care. Any questions? Come and ask me. Thanks a lot. Bye bye.